Claude Opus 5 costs more than 3 times what GPT 5.6 Terra does per million input tokens, $5 versus $1.50, and that gap compounds fast at scale. But Claude Opus 5 just scored 43.3% on Frontier Bench, solving a 3D CAD task no other model could crack in 5 attempts. Both models dropped with big claims this year, and you need to know which one actually fits your workflow right now. So I'm comparing Claude Opus 5 versus GPT-5. 6 Terra across 5 real tests, and everything I'm citing comes from verified published benchmarks and independent sources, no vendor money, no spin. And honestly, the overall result is not what I expected going in. One of these models wins on the thing most people actually pay for, and the other wins on the thing most people say they care about. So which is which? That's what we're going to find out. If you're a developer, a product team, or running any kind of API-heavy workflow, this one's for you, because pick the wrong model and you're either overpaying by 3 times on every token, or you're shipping code that fails on the hard stuff, and getting this right saves real money in real time. All right, so test 1, reasoning speed and latency. When a model is slow, you feel it everywhere. Your users wait, your loops stall, and if you're running agents that chain calls together, a 2-second lag per step turns into minutes of dead time, which is exactly what makes or breaks real-time workflows. Okay, so what I found here is kind of frustrating. GPT 5.6 Terra has a published output speed of 138.9 tokens per second and hits 1.2 seconds on a multi-join SQL task. That's a real measured number from artificial analysis. Claude Opus 5, no published latency figure at all. Its fast mode claims 2.5 times speed, but that's vendor asserted with nothing to back it up. I was expecting Claude Opus 5's fast mode claim to at least give us something to compare, but there's just nothing there. And you can't score a race when one runner didn't show their time. So this one's a tie by default. The data simply doesn't exist to separate them, which keeps us at 0-0 with one tied. Now, test 2, long context handling. If a model loses a thread halfway through a big document or a long code base, it starts hallucinating things that aren't there or dropping things that are. And Claude Opus 4.8 had a known performance drop around 200,000 tokens. So if Opus 5 didn't fix that, you're paying a premium for a model that breaks on the exact workloads it's supposed to handle. So both models come in at 1 million tokens of context and 128,000 output tokens, same on paper. And Anthropic says Claude Opus 5 fixed the 200,000 degradation issue, while GPT-5. 6 Terra claims something called context drift mitigation. But what surprised me is neither of them published an independent retrieval benchmark to back any of that up. Honestly, take both of these claims with a grain of salt, because Anthropic's 200,000 fix and Terra's drift mitigation are marketing language right now, not proven results. And without independent testing on actual long document retrieval tasks, you're just picking which vendor's word you trust more. I went in expecting at least one of them to have a real retrieval accuracy number, and neither did. So this one's another tie. Both models match on context window size, both make vague performance claims, and there's no verified data to separate them. Which brings us to 0-0 with 2 tests tied now. So test 3, cost and pricing. And this is the one that sneaks up on you. You build something, it works great in testing, you scale it up, and your API bill is 3 times what you budgeted. Because if you're running batch jobs or high volume pipelines, the wrong pricing tier doesn't just hurt, it can make a whole product economically unviable. I looked at every pricing tier side by side, and the gap is pretty consistent. Claude Opus 5 runs $5 per million input tokens. GPT-5. 6 Terra is $150 to $250. So Terra is meaningfully cheaper on input, and on output, it's $25 per million for Claude versus $12.50 to $15 for Terra. And on cache reads, batch API, Terra wins every single line. GPT-5. That 6 Terra takes this one cleanly. I was expecting maybe a closer race on batch pricing, but Terra is cheaper across the board on input, output, cache, and batch, and $5 versus $1.50 on input is not a rounding error at scale. So the score moves GPT-5. 6 Terra 1, Claude Opus 5.0, 2 still tied. Now, test 4, coding and debugging. When a model fails on a hard coding task, it's not just annoying, it sends you back to the drawing board. Sometimes after hours of back and forth, and if you're using AI to ship code faster, but the model can't handle complex logic or edge case debugging, you end up slower than if you've just done it yourself. What surprised me here is how lopsided the verified data is. Claude Opus 5 scored 43.3% on Frontier Bench, doubled its predecessor's score, and solved a 3D FreeCAD task that no other model finished in 5 tries. And it debuted second on Senior SWE Bench, while GPT-5, 6 Terra's coding evidence is basically 1 community-reported SQL test, 92.5% on multi-join logic, 89.1% on edge case debugging, and that's it. Claude Opus 5 takes this one, and it's not really close on the verified evidence. I was expecting Terra to have more coding data, but it's basically just that SQL benchmark against the wall of Frontier Bench and Subway Bench results for Opus 5. So Claude's coding story is way more proven, and that ties things up. Claude Opus 5.1, GPT 5.6 Terra 1, 2 still tied. Okay, so test 5, factual accuracy. Model that confidently makes things up is worse than one that just says it doesn't know. And if you're using either of these for research, legal drafts, or anything where a wrong fact has real consequences, hallucination rate is probably the number you care most about, and it's the hardest one to find. So I went looking for hallucination rates, and there's just nothing published for either model. Claude Opus 5 has no factual accuracy benchmark, and GPT 5.6 Terra mentions context drift mitigation, which sounds good, but there are zero numbers behind it. So both vendors are making vague claims without giving you actual data to evaluate. I was really expecting at least one of them to have a hallucination benchmark by now, and neither does. So this one's a tie, which is kind of the most frustrating result in the whole comparison. You can't call a winner when there's no data to score, and that wraps the tests. Claude Opus 5.1, GPT 5.6 Terra 1, 3 tests tied overall. All right, so here's where Claude Opus 5 is clearly ahead. It scored 43.3% on Frontier Bench, solving a 3D CAD task no other model finished in 5 tries. It matches Fable 5 on Cursor Bench within 0.5% at half the cost. And it debuts second on Senior SWE Bench, leading in bug and performance investigation, which makes it the most proven model in this comparison on hard coding tasks. And here's where GPT, $5, 150 to 250 per million input tokens versus Claude's $5, so the per token savings are substantial. And they hold across every pricing tier. Its output speed is a measured 138.9 tokens per second, and on SQL, it hits 94.5% on multi-join logic and 89.1% on edge case debugging, which makes it the better fit for cost-sensitive, high-volume work. Honestly, I went in thinking pricing would be close and coding would be the real differentiator. And pricing wasn't close at all, so here's the decision rule. If you're solving hard coding problems, complex debugging, frontier engineering tasks, anything where the model needs to figure out a novel solution, go Claude Opus 5, because it's proven where it counts. But if you're running high volume pipelines and cost is the constraint, Terra runs at a fraction of Claude's price per token. So pick the model that matches the work.